What if the speed of light was 30 miles an hour?
What if Earth had two suns?
Which cereal mascot would win in a fight?
What if everyone lived underground?
What if it
What
rained
if money grew on
What
trees?
if pigs could fly?
I don't know if that would actually happen.
It's much easier to store a unicycle than to store a horse.
Hello everybody and welcome to Absurd Hypotheticals, the show where we overthink dumb questions so you don't have to. I'm your host Marcus Lehner, and I'm joined here today by Chris Yee and Ben Storms. Say hi guys.
Hey, I'm Chris.
Hey, I'm Ben.
Alright, before we get into today's episode, I do have an announcement. We are going to be going on a little bit of a hiatus for the summer here, namely real life getting in the way. Chris, you're going to travel for work for 6 weeks or so.
Yeah.
My apartment right now is a absolute disaster, mess, crazy box land because I'm moving into my first house. Also, it's taking up a lot of my time here. And, well, Ben, you're just also there.
Yeah, I have some work stuff going on, but it's less intensive as your guys' home and work situations.
So realistically, although we hate taking time off the show because we enjoy doing it, but realistically, it's not going to be feasible for us to prep, record, and edit for the next little bit. So we are scheduled to return on September 27th is going to be our first episode back. That'll give us time to get through this, pick up the recordings again, and get a little bit of a head start so that we can get right back on schedule and continue releasing the lovely questions that you all love.
And I might still be gone at that point, but I think we have someone else lined up to replace me for that.
Yes. Yeah, we may have one or two guest episodes. Might be the first two on the way back, but either way, 927, yes or no, will be the first episodes that'll be coming out for your listening pleasure.
But we still have this episode.
Yeah, we still have this episode, which does have a question, and we haven't done one of these earthy questions in a while, so I'm pretty excited. Our question today is: what if Earth spun 10 times faster?
I'm pretty sure we did an earthy question last week.
I think we did.
It was the continents connected.
Oh, it was. Well, it still, even though we did that one just before, it had been a while before that one. It feels like we haven't done many earthy questions. I don't know. Feels like a long time to me. Maybe 1 week is too long for me to not do a question about Earth.
Marcus has trouble with object permanence.
If I don't see the Earth, how do I know it exists?
Right.
Ben, since you're being a snarky bastard, why don't you start us off?
Oh, that's what I get. So I looked into, obviously, if the Earth is spinning 10 times faster, that's going to change how long our days and nights are. That's where I looked into,
Ben, sorry, before you get too far into it, just parameters. One note, yes, our little parameters here. We're basically saying that the Earth is always spinning 10 times faster, not just immediately starting to go 10 times faster, like an overnight thing. To the surprise of nobody, if the Earth suddenly started moving 10 times faster, it is an absolute catastrophic cacophony of earthquakes, ridiculous strong hurricanes and things. Everyone just dies before anything interesting happens that isn't just immediately apparent of why you don't drastically change the momentum of planets.
And then Ben's shorter day-night cycle really doesn't matter at all.
It does not. Sure does not.
Yeah, it's just going to be one real short day where no one will be there for the night. So that's the only thing I want to add before you jump in, Ben, but go ahead.
Yes. So the first question is, what are our current days like around the world? So it varies based on where you are in relation to the equator. If you're right at the equator, your days are around 12 hours long all year long. I actually look up a city in Ecuador called Quito, I'm not sure, which is about 16 miles south of the equator. And there, the daytime was, it was from like 12 hours and 5 minutes to 12 hours and 8 minutes year round, so pretty constant, 12-hour day, 12-hour night. For us, we're all around Boston on this podcast. It does fluctuate based on the season. So as we're recording this, we're actually just coming up on the summer solstice, which is June 20th. It's obviously already passed. We're listening to this, but on the solstice, which is the day where the day is longest and nighttime is shortest, the sun rises 5:07 a.m., sun sets 8:24 p.m., so the daytime is about 15 and a quarter hours and around 64% of the day. And on the contrary, the winter solstice, which is in December 21st, it's kind of the inverse. So sunrise is 7:10 a.m., sunset's 4:14 p.m. So the daytime is only about 9 hours. It's about 38% of the day. So obviously, if you have 10 times faster days, 10 times faster rotation of the Earth, you're going to have days that are a tenth as long. So your 24-hour days become 144-minute days. And when you split them based on, your latitude, you're going to range from either around 72-minute days and nights to the equator to it's about a 90/50-minute split. 90 minutes a day, 50 at night in the summer, 50 minutes a day, 90 minutes a night in the winter at our latitude. So this obviously is going to mess with our sleep schedules a little bit because suddenly we don't have these nice long periods of time that are dark that we would naturally sleep in. And if we were to just sleep at night and wake up in the day, how does this affect us? Conveniently, there are actually people already who kind of sleep under the sleep schedule. Most people use what they call monophasic sleep schedules, where you have one period of sleep, one period of wakefulness. But there are polyphasic sleep schedules. The most common ones are the Dymaxion, Uberman, and Everyman schedules. So the first one that was kind of developed was the Dymaxion. It was developed by Buckminster Fuller in the 1920s. He was an architect and futurist, which, by the way, getting described as a futurist on Wikipedia, it has to be such a huge life goal, right? That's just an awesome thing to be referred to as.
I don't think you ever get referred to as a futurist unless you've annoyed enough people at parties. You have to go pretty far into wouldn't it be cool in the future if we had X, Y, and Z to get labeled as a futurist?
There has never been someone described as a futurist who has not also been described as tediously annoying. I can guarantee it. So on the Dymaxion schedule, you basically took 4 30-minute naps every 6 hours, which gives you 2 hours of sleep a day. After that, in the mid-90s, Marie Staver, who was an amateur scientist and IT professional and insomniac, who was inspired by the Dymaxion schedule and Buckminster Fuller's research, made the schedule. Basically, she sort of tweaked it and did 6 30-minute naps every 4 hours. So you got an extra hour of sleep in there. And then eventually she got a job where she couldn't do that and made the Everyman schedule, where you do one core period of 3 hours of sleep, which for her was usually 1 to 4 a.m., and then 3 20-minute naps throughout the day. And the people who use these systems say that your body adjusts to it and you still get all the sleep you need, and you have all this extra time in the day to do things. You're more productive. Does that actually work? Not really. There have been some studies researching these because they have become kind of a, or I guess they were for a little while, sort of a buzzwordy, popular thing to consider doing. There was a 2017 study from Harvard Medical School and Brigham and Women's Hospital in Boston, where they looked at college students who used these irregular sleep schedules versus, more standard monophasic sleep schedules, and saw that people on the polyphasic sleep schedules had lower academic scores as compared to the monophasic sleep schedule.
Maybe they had lower academic scores because of the people that looked at these, crazy sleep schedules yeah, that seems like a good idea.
So I feel like you need I don't know what the control group is, but I feel like there could be some amount of selection bias there. I agree. There was also a study in Oman in, I don't actually have the year of that one, which it was 400 volunteers. And that one concluded as well that polyphasic sleep had high levels of daytime sleepiness and just impaired performance compared to people on a monophasic schedule. That one did find that a biphasic schedule with an afternoon siesta was the best sleep schedule. So I'm going to start telling my boss that and see if I can get, pull that off and start getting on that schedule. But obviously, this isn't exactly the way that it would be for us, though, on this schedule, because 1, we still be sleeping the same amount. It would just be across more times. And 2, this wouldn't be fighting our natural rhythms. Because a lot of the problem is that there is this concept that I'm sure everyone has heard of at some point called circadian rhythms, which are these sort of internal processes that regulate our sleep-wake cycle that are sort of based on this 24-hour clock of the, day-night cycle. And if you think about it, evolving to sleep, to have these long periods where you are unconscious and, not moving for hours, feels like a really weird thing to evolve from a survival standpoint. Because it feels like, obviously not a great way to avoid predators.
Have they ever figured out why we bother sleeping in the first place? Has someone in the last 10 years answered it? Because I know the answer was no, not too long ago.
So I looked into it. The answer is still mostly no. We don't completely know. The main takeaway, so there are definitely a lot of theories. We know that the body does have to rest, but there's not necessarily a great answer as to why we actually sleep as opposed to just, going into a lower power usage state, basically, and kind of trancing or whatever, and still being aware of our surroundings. The theories, a lot of them involve, there are like toxins that build up in your brain that you have to flush out. And there's been some research showing that there are like increased, I don't remember what exactly it was that was happening, but they were like flushing out like proteins and toxins in your brain while you were sleeping that you have to be, unconscious for. But the bigger thing that people sort of theorize is that there are obviously lots of predators at night, and humans do not have, or I guess, and many animals do not have great night vision. And if your body is going to have to rest anyway, what you can do is go into this sort of dormant state and avoid moving, sort of get to a quote unquote safe place and effectively hide and just do all your recovery at night when you're not very good at moving around anyway. And the idea is that it was basically a shortcut evolutionarily to avoid having to evolve night vision, which is pretty funny to me.
Night vision or unconscious
time? Let's just sleep. That's fine. Yeah, you know what? That sounds like a lot of work. I'm just gonna sleep instead.
Which one of these is gonna help me survive more?
I mean, apparently it worked. We're here. I don't know. Who would have thunk it? The other thing I did see in terms of having this, day-night cycle, because, obviously there are animals that are nocturnal as well. One of the reasons it can happen is if there are two species that both like hunt the same prey, a lot of times one will evolve to be a nighttime predator and one will evolve to be a daytime predator. So you look at like falcons or eagles and owls, where, a lot of birds of prey hunt in the day, owls hunt at night, and they have less competition because the other birds of prey didn't evolve to hunt at night. So that's how they evolved this sort of flipped schedule. They're awake at night and asleep in the day. In terms of humans, biologically, there's nothing holding us to that 24-hour clock. And actually, if humans are isolated from the sun, weird shit happens. So there was this pair of experiments in 1965 where these two people, one man and one woman, both went into their own like individual caves and just sealed themselves in. Just in complete isolation, no sunlight. They had, I think, some, unnatural light down there, obviously, but they pretty much just went down there and lived. And they had radios and they were communicating with scientists outside, sort of tracking their sleep and things like that. But they were pretty much just isolated from the outside world. Each of them set at the time world records for isolation. The man was in there for 126 days, the woman for 88 days. And when the woman came out of the cave, she came out of the cave on March 12th and thought it was February 25th. The man came out of the cave on April 5th and thought it was February 4th. So he lost 2 months in his mind.
Jesus.
And apparently there were times where, because he had no link to the sun or anything, he would just go to sleep for like 30 hours and then wake up and not realize he'd been asleep for that long. He thought he took like a short nap, but he was just out for 30 hours. And then there've also been other studies where, in situations like this where people are in, bunkers or caves or whatever, people will, frequently switch away from a 24-hour cycle to one that's, 28 hours or 20 hours, something like that. But sometimes in like certain instances have gone to 48-hour cycles where they're sleeping for 24 hours and being awake for 24 hours, which is obviously very, very strange. And that kind of gets me to sort of the sadly uninteresting main takeaway of all of this, which is if our days were 10 times faster, and even if it did happen overnight and we somehow didn't all get flung into space or earthquaked or hurricaned away or anything, we would over time, or just, as we evolved, adapt to it and probably just be on a 60-minute awake, 60-minute asleep roughly cycle, because it feels like that's just kind of how species have evolved. We have evolved to match the day-night cycle. That's the kind of boring answer.
That works out pretty perfect for me though, because you can kill about an hour at the office if you if you take your time making your coffee and kind of getting your stuff together and setting up. So you can just ride that, I just woke up, I need my coffee, and kill that first half hour of every hour wake cycle, and you don't have to do a lot of work anymore.
I actually was trying to think about what an office environment would be, and I feel like it would have to be, just in terms of having any kind of productivity, there would have to be it
would have to be a nap room.
Well, I think it would be, you would have an office with a desk and a bed, and everyone would just work for an hour and then sleep for an hour at work.
Because you can't just commute every day. That's a huge waste of time.
Right, yeah, it would never work. You would just spend, in your mind, 10 days at a time at work, and then go home for like 10 days. It would be super weird. So, I mean, obviously there'd be lots of changes, but it's just, all of this is evolution, you know. If we ever go to another planet, colonize somewhere, and it has a different day-night cycle, I'm sure we won't be on an 8-hour clock there eventually, because it's just how the body works.
And when would we eat? When would lunch break be?
Lunch would be every 4 days.
It would be lunch day.
Yeah, it would be lunch day, exactly.
Yeah, guys, I ordered my food 2 days ago. I'm just trying to check in where my pizza is.
I ordered. I'm gonna go sleep all night. Can it be here when I wake up, please? So yeah, that's you know, not maybe the most exciting answer, but the answer is just that we would sleep in the day sleep at night and be awake in the day still. It would just be weird and short. So there you go. Chris, what did you do?
So for this question, for my answer, I wanted to look at the centrifugal force part of this answer, because the Earth is spinning, which means that there's going to be some force that it's going to like counteract gravity and stuff. And I want to look at that. So the first thing I looked into in regards to that is something called equatorial bulge, which basically means that at the equator of the Earth, the radius is larger because it's spinning. So right now, Earth is currently 27 miles wider at the equator than at the poles. It has like a larger radius. Now, I found an equation for like calculating the equatorial bulge and like how wide the radius is. And it's a square relation to the angular acceleration, I think. Angular acceleration. Or angular velocity, I guess.
Which scientist gets to put his name on the equatorial bulge equation?
It's an interest. Yeah, they called it a bulge. It is a choice.
I mean, it is. It's accurate.
It is a bulge.
It's referred to as a
true.
bulge. Yeah.
Yeah. So it is a square relationship, which means that even though the Earth is only rotating 10 times as fast, the bulge is going to be 100 times as bulgier. So that means that instead of 27 miles, the Earth is going to be 2,700 miles wider at the equator than at the poles. So it works out to being like about twice as wide at the equator than at the poles. So like at the equator, the radius is going to be 53,000 miles, where at the poles it's going to be 5,300 miles, not 1,000, versus 2,600 miles at the poles. So you get this like really exaggerated sort of disc shape, not really disc shape, but I think they call it like an ellipsoid.
It's like an M&M.
Yeah, like an M&M. That's a good analogy. So that's the first thing. The Earth is going to be weird shaped. The second thing is that obviously it can affect gravity, and people are going to be lighter at the equator. So there are actually two things happening here. The first thing is the centripetal acceleration counteracts gravity. And then the second thing is that at the poles, you're going to be, because the shape is different, at the poles you're going to be closer to the center of the Earth than at the equator, which means that at the poles, gravity is going to be stronger. And at the equator, gravity is going to be weaker just because of the shape. Nothing to do with like the actual rotation of the Earth. So those two things combined for normal Earth means that gravity is 0.5% less at the equator than at the poles. Now, with our new shape, if you're just considering the new shape, that means that we would have half the amount of gravity at the equators than at the poles, because you're twice as far away from the center of the Earth. And if you're only looking at the centripetal force, that means, so right now Earth is rotating at 460 meters per second, as that's our normal rotation. But since we're rotating 10 times faster and the shape is actually larger, the circle is bigger, which means that we're actually rotating faster than 10 times at the surface of the Earth because the circle is bigger. So the new rotation of the Earth is actually 6,211 meters per second at the equator. And that works out to a centripetal acceleration at the equator of 4.5 meters per second squared, which is almost half of normal Earth's gravity. So as you might have noticed, the first number, according to shape, is halving the gravity. And then, according to centripetal force, I'm almost halving the gravity again. But it's not like halving. It's like minusing what's already there. So the new gravity, based on these two things, the new net acceleration at the equator is 0.4 meters per second squared.
Oh, damn.
Yeah, which is 4% of our current gravity. And we just barely don't get flung off of Earth into outer space. Which is a good thing, I guess. We can still stay on Earth. Now, that's only at the equator, so like as you move closer to the poles, gravity will increase. And at the poles, it'll actually be a stronger gravity than what we have right now. It'll actually be 2.3 times our current gravity because we're closer to the center. And then there'll be like a large range in between. Now, another thing that's going to happen is that the water on Earth is going to shift to the equator because of the centrifugal force, which means that the ocean level is going to rise at the equator. Now, I couldn't find exactly how much it would rise. I found an article that said, there was like an expert in there that said that if the Earth was rotating 100 miles per hour faster than it currently is, then ocean level would rise 30 to 65 feet. And then if it was rotating double the speed, it would basically cover most of the land, but except for like really tall mountains and stuff. So based on those two things, if Earth was rotating 10 times faster, it would definitely cover all of the land at the equator. There's really no question about that. So yeah, basically just all the land at the equator would be drowned, but then that water has to come from somewhere, and it's coming from the poles. So all the water at the poles would be drained, and you'd basically have these two supercontinents, the northern and southern hemisphere supercontinents, separated by an ocean in the middle. So, and you get like incredibly arid climates like away from the coastlines. But theoretically, there'd be like a habitable area like along the coastline, maybe. I'm not entirely sure, but maybe.
There's got to be a spot in between where the numbers average out to about the same of what we're doing.
Yeah. And I don't know if that like lines up with where the gravity would be the same as ours either. I didn't really look into that, but because there's less gravity at the equator and all the water is going to be at the equator, the less gravity actually means that the oceans humidify easier because less gravity to like keep it all in a liquid. So we're going to have like really dense fogs and really thick clouds over the ocean too, which is going to make it really hard to sail. Now, even though it is very difficult to sail, and it'll probably be just like this giant ocean that's almost uncrossable, I still think people will try to cross it. So like boats, like explorers will try to sail over it. And eventually I think it will lead to us discovering that the equator does have a weaker gravity. And I think this will lead to us trying to explore space earlier because of this. So I think space exploration will sort of take the form of us sailing to the equator and then trying to launch into space from the equator from our sailboats. Now, we only need a small amount of thrust from the Earth because gravity is only 0.4 meters per second squared. So we only need to meet that in order to leave Earth. Now, the average acceleration of a cyclist is around 0.2 meters per second squared. So we only need double that to leave Earth. Now, a sailboat or like a pirate ship sort of thing is heavier than a bike, obviously. So we'll need a little more force than just two people pedaling a bike to leave Earth. So I want to figure out like how much force we would need to make a pirate ship leave Earth from the equator. So I looked at some sailboats. I looked into like the Nina, Pinta, and Santa Maria, just as like an example. The Santa Maria is the largest of the three, so I looked at that one. And it weighed around 150 to 250 tons, depending on how much cargo it was holding. I just went down the middle and said 200 tons. And with the weaker gravity at the equator, we would only need 160,000 pounds of force on the ship in order to leave Earth. Now that 160,000 pounds does sound like a lot, but the space shuttle right now takes about 7 million pounds to leave Earth. So 160,000 pounds is only about 2% of that. So it's very small. Now, I wanted to try to like figure out how we would generate this force to leave Earth. And I liked the idea of using cannons because we're on a pirate ship sort of thing. And just like pointing them down and then shooting all the cannons at once. That would be cool. But I couldn't figure out, like, it's surprisingly hard to find the numbers on how much force a cannon generates. I thought it would be easy, but apparently it's not. So that's like my ideal situation. But if that doesn't work, then a Boeing 747 takes about 50,000 pounds of thrust to fly. So we basically just need to take a few jet engines, strap them to our pirate ship, and then we'll be able to go to space. And you'll have these cool space pirate ships, and it'll be cool. Space pirates.
I'll say, given that you need 4 jet engines to get to space, I don't think the cannons would have worked if you had found the numbers.
Probably not. Well, you'd probably have a lot of cannons. That would be my answer. Like, I wanted to figure out how many cannons you need, but I couldn't find the numbers. It was really annoying.
Yeah, you could maybe you can look at there's this one giant cannon. I forget what it's called. It was probably just called like the Tsar cannon or something that Russia was working on during the World Wars. That was just overly gigantically huge for no reason. It was
the train mounted one, right?
I think the Europeans or the Germans made the train one. The Russians wasn't so sophisticated. They had it. I just remember that every time the thing fired, it broke itself from the recoil.
Oh yeah, that one.
And then they outfitted similar ones to their boats, and the cannons would also bend the ship hull when they fired.
Right.
It was not a good. They had very strong. They were very good at making very strong cannons, but not so good at coordinating that with what they're attaching them to.
Maybe the best historical example of you were so busy figuring out if you could that you didn't figure out if you should.
Yeah, exactly.
Well, you should if you could get to space with it.
Fair. That's absolutely fair.
Speaking of space.
Oh yeah, Marcus. I didn't transition to you, Marcus. What's your answer?
Speaking of space, what I actually started looking at, considering you guys were doing the day-night cycle and all the gravity stuff, I was looking at some more niche things, and what popped into my head was the magnetic field of the Earth. So basically, the Earth generates a magnetic field that surrounds it, and this is generated because the spin of the Earth stirs up the molten iron core. All those molten metals in the Earth's mantle and core spin around with the rotation of the Earth, and those spinning metals will generate that magnetic field. This magnetic field is what keeps the Earth safe from all that nasty radiation from the sun that would otherwise, fry the planet and, strip the atmosphere and all these other not nice things. So what if we spun faster? Because if we spun faster, we're speeding up all these molten metals and we're kind of supercharging our magnetic field. So I'm like, okay, what happens now? And not a whole lot is the big takeaway, because things that'll change, like the magnetic pull to magnetic north, that animals use to sense and migrate, would be a bit stronger. So maybe that messes with some of the animals. I was actually looking a little bit at humans. Human eyes actually have a significant amount of the flavoprotein cryptochrome, which is used by other animals and theoretically has the ability to detect magnetic fields. So in our eyeballs is actually the right biological material to detect magnetic fields. Our brain just doesn't use those chemical reactions it doesn't do anything with them. But it's kind of cool to think that if the magnetic field is stronger, we might evolve to be able to start sensing that, magnetic north. That would be kind of neat. Because honestly, I want that ability, because my car doesn't have a compass in it. It doesn't tell me which way north, south, east, and west is, which...
I mean, you could just carry a compass.
It doesn't work in a car, though.
You could just strap a compass to your mirror.
Well, no, because it jiggles too much.
You could just get a car with a compass in it.
Yeah, I could do that, but they don't make them with compasses anymore. Everyone just thinks you're using your GPS. I miss the north, south, east, west in the car. But that's my own personal battle. So kind of going from there, I was looking to see if, okay, we're blocking, we block some radiation from the sun, but some radiation still gets to Earth. I was trying to see now, if we supercharge it, does it block too much radiation and kind of reduce the amount of energy we get the sun, kind of turning us into a cold ice planet? That would kind of suck. And despite the things I'm saying, it turns out the magnetosphere doesn't actually block radiation, which is most of the energy that we get, all the different energy wavelengths, but actually instead blocks solar wind, which is actually the physical stream of charged particles. So the sun kind of shoots out like these, plasma jets and these electrons and protons that have these this charge, and that's what the magnetosphere protects from. These things are nasty. I mean, it starts off as plasma and then shoots out these high energy particles. That's what would be dangerous and mess with us. And the magnetosphere basically blocks all of them. Like, it just does a pretty good job. The exception of what blocking, which was interesting to me, is at the poles. Like, if the magnetosphere kind of is like a bubble in front of the Earth and a big tail behind it, but they kind of come together at the poles. It kind of just like, I'm trying to think of a good way to explain it visually. if you take like a wire and put it in the center of the Earth and then just like loosely carry it around to the bottom, and so it makes like a big arc around, and just do that 360 degrees around, that's kind of what the magnetosphere looks like. And actually at the poles is kind of like it makes like a funnel at the top. And the solar winds actually will carry these particles into this funnel and hit the poles, and that's actually what's generating the aurora borealis. So that's why they're more northern.
It's like the shape of an apple, kind of.
Yeah, a shape of an apple, but like emphasis on the part where it goes back inwards toward the stem.
Yeah.
And the stem would be the North Pole, and that's where you get that aurora going around, because it'll kind of funnel those energies into there. So there's a potential that if you have a bigger funnel, it makes bigger auroras, or if you have a big long funnel, less of it makes it all the way down the funnel, less auroras. I'm not sure. But not too much super exciting going on with the Earth. But I also looked at the moon, because the moon is pretty far away from Earth. It only spends about a third of its time inside Earth's magnetosphere. So going back to the shape of it, you have your nice apple, and the solar winds are coming from, the left side of the apple, say, and they hit it. But actually, there's a tail behind it, so it compresses the left side of the apple, and the right side of the apple actually extends out back behind the Earth into space. It casts like a shadow. So when the moon is behind the Earth, it's inside its nice, protective, safe magnetosphere. The front of it, though, is compressed. So when the moon is in front of the Earth, it's very much exposed, because it only comes out 40,000 miles in front of the Earth, but the moon is 238,000 miles away. So I couldn't find the exact equations for how the speed of the Earth would impact the strength and size of the magnetic field. But let's just say, for the arguments of this podcast, that it extends out 10 times further. Because you have 10 times stronger field, the distance it extends out is 10 times further. We're now going to have a 400,000 mile radius of magnetosphere around the Earth everywhere. And now the moon will be completely protected. Now, once the moon is completely protected from the solar winds, what the moon can start doing is the moon can start building an atmosphere. Right now, the moon technically has an atmosphere. It's got some weird gases in it, like potassium and things, and it's so thin that they describe it as a atmosphere where the particles don't actually collide with each other. They're just free to roam around because it's so, not dense. But assuming that it's better protected, it has more of a chance to build an atmosphere. And if we say that the Earth, the situation was always like this, there's a good chance that the moon would have some amount of atmosphere, and it might actually be potentially habitable, because they've also, if you're following recent scientific discoveries, they're finding a bunch of water on the moon. The poles of the moon have a lot larger ice water reserve than they expected, and so it's kind of throwing a little bit about what we know about the moon in the air. So theoretically, you could go take your Canon spaceships and just go colonize the moon, because you don't have that much good space on Earth anymore. There's so many places that are not good to live in anymore. So you might just want that little bit of extra real estate. But the time to act, I will warn this, the time to act is now. Because in addition to all the magnetosphere stuff, the Earth spinning faster will have one more effect on the moon, and specifically its orbit. So right now, as we speak, the moon is escaping Earth's gravitational field. It is getting further and further away. It moves out 1.5 inches each year, which the website helpfully described as about the rate at which your fingernails grow, which is a pretty aggressive and rude comparison, I think, and not super helpful when I'm trying to think about space distances. But the reason the moon is moving further away from the Earth is that when the moon comes to Earth, it pulls a blob of water towards it. That's the high and the low tide. The gravity of the moon pulls a little bulge of water towards the moon. Now the Earth is spinning, so the Earth pulls that little glob forward of the moon. And now that little bit of extra mass is ahead of the moon and pulls the moon along, speeding it up ever so slightly. So now that the Earth is spinning that much faster, it's going to pull that water bulge that much further ahead, speed the moon up that much more, and really not make any difference. I'm just saying it because it's fun facts.
Wait,
if it goes from 1 inch a year to 10 inches a year, it's not going to make an impact. We're talking about hundreds of thousands of miles.
Fingernails only grow an inch a year?
Inch and a half.
1.48
inches.
It's more
that sounds about right. No, that sounds about right.
Sounds slow to me.
How often do you have to cut your fingernails?
I cut my fingernails a lot.
Fair enough, all right.
I don't cut my fingernails that much, and they do get long, but not that long.
Yeah, never like a quarter of an inch long.
Yeah, but I cut it more than 4 times a year. Or, I guess
6 times a year.
6 times a year.
And you're probably not making it past... Even an eighth of an inch is like a long fingernail. I don't really specifically want to talk too much more about fingernail growth. just gonna throw that one out there. So I'm gonna use my powers of the host to jump us into our Would You Rather segment.
I have a super dumb Would You Rather question that I found when I was Googling last week.
I'm in.
Let's do it.
All right. Oh, do I have to intro it?
Yeah.
Oh.
This is the first time you've done this.
You have the question, Ben. You have to do it.
Oh, God.
Who are you going to choose?
Oh, yeah. That's a very good question. So, yeah. So I have a very stupid Would You Rather question from Googling last week when I Googled Would You Rather questions that aren't bad. And I found this one, which, jury's still out. So, Marcus.
Yes. I'm ready.
Would you rather have a 10-inch long belly button that swayed to music or accordions for legs?
What? What? You said 10-inch long?
10-inch long belly button that sways to music or accordions for legs.
I
realize these are very different situations.
I know what Chris is going to say, because practically the accordion legs are way worse than the belly button.
Well, it depends on how much control you have over your accordions, because they're more flexible than normal legs.
That is true.
You just could cartoon it up and be big long strides. Although the noise would probably be just absolutely an insurmountable obstacle. That said, what I am really worried about with the belly button is that it can't not, like, when you find the girl who accepts your 10-inch belly button that sways around, it can't not be involved in the bedroom. And I don't know if
you're cool with that.
If I'm cool with someone who's cool with that.
Right. Yeah, that's fair. We're not kink shaming here, but we're kind of kink shaming here.
It's not so much kink shame, but it's, it just wouldn't be for me. My 10-inch belly button would not be a thing for me, I don't think. And I don't think it can be a thing for you unless it's really a thing for you.
So, like, a belly button is obviously easier to hide. The fact that it sways makes it a little harder to hide when there's music.
Well, where do you put it, though? Like, do you, like, wrap it around your waist?
Well, I mean...
Belt loop?
I imagine... Yeah, like, it's not just sticking out. Like, you can just put it against your chest or something, I guess.
But, like, what if music comes on and it starts swaying around? Like, people are going to notice.
That's the problem. But, like, people are always going to notice your accordion legs.
That's way... Okay, this is not something I expect you to say, but it is not that hard to explain accordion legs compared to your 10-inch musically swaying belly button.
Yeah, that's actually true too. Where you have accordion legs, no one would if you told someone that someone had accordion legs, they wouldn't believe it. But once you show someone your accordion legs, like, you're like, "Yep, those are accordion legs." There's no real follow-up questions.
I mean, I think a 10-inch long belly button is more believable, like, in real life, other than the swaying part.
Which is kind of the problem. Where I think there's just too many questions about the belly button. It falls right in that space of things people think it's polite to not mention, but super duper want to mention.
It's 10 inches long and it sways to music?
The fact that it's, like, fleshy, whereas the accordion legs aren't, makes the belly button way grosser.
This is true. This is definitely true.
Does it sway in rhythm to the music?
Oh, I assumed so.
I hope so. Why would it sway out of rhythm?
If it does, could
you be a conductor?
You could be either a conductor or a drummer because now you have a fifth thing that's just holding the beat for you. You just throw a little, like, I don't know, a thimble on the top and just put some bongos on the left and right, and you can have you have a fifth part that you can make music with.
That is, I suppose, true.
Then again, if you have accordion legs, you're also adding an instrument or two to the one-man band.
You also, I'm sure, could be a very successful street performer if you had accordion legs. Whereas if you try to show people your 10-inch long swaying belly button, you're going to get the cops called on you.
Yeah, I mean, the accordion legs that's definitely the answer where you try to show it off and like use it to your advantage, whereas the belly button is you trying to hide it.
Right.
I feel like the accordion legs would get really annoying eventually, though, if they are making noise.
I feel like the belly button would too. I don't know.
Well, the belly button, like, music isn't playing all the time, so like most of the time you can probably hide it. You just got to stay away from music.
Yeah, but like anytime, basically any store is gonna have like music playing. Like anytime you're in an elevator, that's not true. Elevator music isn't really.
But like
anymore.
when it kicks in, it's just gonna be weird. Whereas like the accordion legs is gonna be annoying to other people as well.
Imagine trying to raise like an infant with accordion legs.
Wait, are you saying you're trying to raise an infant that has accordion legs, or you're trying to raise an infant while having accordion legs?
While you have,
because both are very
one,
difficult
the second
situations. Okay.
I guess you don't always need to walk places. You can use like a wheelchair or something.
Just a skateboard around the house.
All right, someone's gonna have to take a stand at some point. I think I know what my decision is. Personally.
I'm kind of split. I'll make a last minute decision.
All right, should I start then?
Go for it, Marcus.
All right, I'm as weird as it is. I'm gonna pick the belly button. I think that 90% of your problems could be fixed by just like Spanx.
What? What does that mean?
Like you just have the shapewear that'll just hold it in place against your torso.
Not being spanked, as Chris thought you meant.
Spanked with an X, yeah. At which point you've solved it, and yeah, there's probably there's got to be that unicorn girl who's cool with it but not into it. Maybe you can get it. Maybe there's a procedure. Maybe you can get it removed eventually. That doesn't seem like too hard a thing.
Yeah, you just cut it off.
So yeah, I'm landing on belly button.
I'm going to go accordion legs. I just feel like trying to hide it is going to give you so many complications. And I do think that people, like, if you just matter of factly say, yep, I have accordion legs, people are going to be like, that's weird, but okay. Like, I think there's just so many more questions about the belly button. And it's just going to, I don't know. It just feels much, much weird to me. I don't know.
Okay. I think it'll be weirder. Like, I think more questions come with the accordion legs, definitely. But people will more easily accept it, I think. Like, it's weird, but it's also kind of cool after
it's weird in a more understandable way, right?
Yeah, whereas the belly button is weird, and then after the initial shock, it's just gross. You can probably hide the belly button easier, but I think if I had accordion legs, I probably wouldn't try to hide it. I would just embrace it. I think I'm going to go with accordion legs because of that, and I guess I would try to build a career off of it or something. It's a lot easier to build a career off of accordion legs than a belly button. So I'm going accordion legs.
Well, then that is that then. We have all made our determinations. If you enjoyed this episode or have strong opinions about belly buttons and or accordion legs, you can leave that opinion over in a review for the show. Having reviews is a great way to help grow the show. It lets people, it tells people that you enjoyed it, lets us bump up in the search rankings and all that. And God knows I don't listen to a podcast unless it has 3 dozen reviews that are all, it's like 3 dozen good ones and like a couple bad ones just to make sure that they're honest. And then, but start with the good ones first. Don't leave the bad ones until we got a nice set. If you want to more directly help the show, you can go to our Patreon, www.patreon.com/absurdhypotheticals, and become a patron. For just $1 a month, you get access to all our bonus content that's exclusive for our Patreons that we release each month. And if you want to be part of the show in your own special way, you can send us a question. We love getting listener questions. The best way to send those is via email to absurdhypotheticals@gmail.com. Nice and easy to remember. And normally this is where I say next week's question, but we're going on a hiatus, so it is TBD for the first time, I think.
We will still be doing the Patreon episodes, though, so if you want to keep on hearing us talk, you can go to Patreon.
Yeah, if a hiatus isn't for you, and you want more of us, and then you just can't stand it, you can pay for it directly. That's how it works now. we're drawing a hard line. You want more of the good stuff? Cough up that cash.
I have no idea what we're going to talk about in them, but that's kind of the point of them. We just talk about whatever, so.
Exactly. Again, we're returning September 27th with the weekly free episodes, and we'll be back on track from there. Again, just a bit too much of real life getting in the way of our fun pastime here. And with that, I'll see you then.